The Claude versus Codex benchmark had no real winner. The folder won. One Chinese creator gave the exact same YouTube video job to Claude Code and then to Codex. Her reported result was messy in a useful way. Codex looked faster and used fewer tokens in one comparison. Claude looked more polished and needed fewer retries. But the important part was that she moved the project from one agent to the other in about 3 minutes. The work survived because the workflow, project memory, and acceptance checks were stored outside the model. That is the headline. Models are replaceable labor, but a well-built project is the operating system. Start with the setup, because this was not a clean laboratory benchmark. The creator had been producing marketing assets with Claude Code and exhausted the capacity on her plan. The job still had to ship, so she opened Codex and asked it to continue. That is not normal model selection. It is a relay race. In a selection test, you ask which runner is fastest. In a relay, you ask whether the baton can move without the whole team starting over. The baton in this case was a real project directory. It contained instructions, reusable skills, source material, progress notes, and a definition of done. The task itself was not small. She wanted a complete long-form YouTube video, not a single script. The pipeline included research, a roughly 5,000-character draft, story structure, scene planning, asset collection, diagrams, voice, a digital presenter, B-roll, editing, and repurposing for other platforms. She estimated that a person might spend about 3 days doing the whole chain manually. Her advantage was that those decisions had already been written down. The project contained a YouTube scripting skill. It contained a long video to short video skill. It contained repurposing routines for social posts, newsletters, and other channels. It also contained rough cut and fine cut procedures. So when Codex entered the project, she did not teach video production again from zero. She asked it to read the existing system, create the instruction file it needed, preserve the original files, and continue the work. She also asked for a synchronization tool and a shared task log, so the next handoff would be easier. The official product mechanics now support the same pattern. OpenAI documents that Codex reads AGENTS.md files before it starts work. Anthropic documents that Claude Code reads CLAUDE.md as persistent project context. Anthropic also recommends importing AGENTS.md from Claude.md when a repository needs shared instructions across tools. And agent skills are explicitly file system-based packages of workflows, scripts, templates, and reference material. In other words, both ecosystems are moving toward the same primitive, portable operating knowledge stored as files. Now look at the reported numbers, but keep the labels attached. The article shows a creator-reported run of more than 9.5 million tokens for one production workflow. It also describes 29 scenes and roughly 60 agent executions across planning, production, and review. The article also contains a separate comparison snapshot, so its token figures should not be combined or treated like a universal benchmark. The useful signal is the scale. An agentic media pipeline repeatedly reads context, generates assets, checks output, and revises. The organizational pattern matters more than the raw total. The expensive model was used to define standards, coordinate work, and review results. Cheaper workers handled more of the execution. Then the stronger model returned for acceptance. That resembles a real company more than a chatbot. You do not ask the most senior person to resize every image. You ask that person to define what good looks like, assign the work, and reject what fails the standard. The same principle is showing up in coding, research, customer operations, and content production. This is also where a lot of agent demos go wrong. People hear the word loop and assume that repetition creates reliability. It does not. A loop without a measurable stop condition is just an automated way to spend money. The agent writes something, criticizes it, rewrites it, finds another possible improvement, and keeps moving because nobody defined the point at which the work is acceptable. More intelligence does not solve that governance problem. It can make the waste faster, more coherent, and more expensive. So what exactly must survive when the model changes? The first asset is procedure. That means the sequence of work, the tools, the required inputs, the expected outputs, and the known failure modes. A good skill is not a motivational paragraph. It is an executable operating manual. If the procedure only exists in one conversation history, it is not portable. The second asset is state. State is the record of what has already happened. Which sources were checked? Which files are final? What failed? What still needs a decision? This can live in a task file, a manifest, structured logs, or a database. State is what turns a handoff from a restart into a continuation. The third asset is the stop condition. For code, that may be a test suite, a type check, a security scan, and a performance budget. For a video, it may be duration, caption coverage, audio consistency, source traceability, black frame checks, and a human review of representative frames. For customer support, it may be policy compliance, evidence citations, escalation rules, and a confidence threshold. If you cannot state the acceptance criteria, you do not have an agent workflow yet. You have an open-ended suggestion engine. This changes how you should calculate model cost. Token price is only one line. The real bill is generation cost plus tool cost plus human review plus the rework tax. A cheaper model that needs 4 read trees can cost more than an expensive model that passes once. The right architecture routes work by risk. Use the cheaper worker for reversible, easy-to-check tasks. Use the stronger model for planning, ambiguous judgment, and final review. Escalate to a person when the downside cannot be repaired by another pass. There's an uncomfortable consequence here. Better agents make weak operations more visible. When a human team has vague standards, people quietly compensate with meetings, memory, and overtime. An agent does not possess that invisible social glue. It follows the system you actually documented. If the project is disorganized, the agent scales the disorganization. If the checks are missing, it scales uncertainty. If ownership is unclear, it produces a larger pile of plausible output that nobody can approve. Portability also has limits. Claude Code and Codex do not expose identical tools. Their context handling, permission models, sub-agent behavior, and default judgment are different. A skill built around one proprietary command may not run unchanged somewhere else. So model independence does not mean pretending every agent is identical. It means keeping the durable layer neutral and isolating provider-specific adapters at the edge. Here's the practical architecture I would use. At the bottom, keep a canonical source folder with evidence and rights information. Above that, store the workflow as small skills with explicit inputs and outputs. Keep project state in a manifest and a task log. Put machine-checkable acceptance tests next to the work. Then create a thin adapter for each agent. AGENTS.md for Codex, Claude.md for Claude Code, and tool-specific settings where they are truly necessary. The adapter should point to the same source of truth rather than duplicating it. Then test the handoff before an emergency. Give 2 agents the same bounded task. Do not ask which answer feels smarter. Measure time to first acceptable result, total retries, human correction time, and cost after rework. Record what each agent misunderstood. Turn those misunderstandings into clearer instructions or better tests. The goal is not to crown a permanent winner. The goal is to make the next switch boring. For an individual creator, start with 4 files. Create 1 instruction file that explains the project and the non-negotiable rules. Create 1 skill for the repeated workflow. Create 1 task log that records current state and decisions. Create 1 acceptance checklist with commands or observable pass conditions. That is enough to move the valuable context out of a chat window and into an asset you control. You can add orchestration, multiple models, and automatic routing later. For a company, the same idea becomes an operating layer. Procurement can change model providers without rewriting every process. Security can review the shared workflow instead of chasing private prompts. Teams can compare models against the same evaluation set. The moat is not access to a model that every competitor can buy. The moat is the accumulated definition of how your organization produces acceptable work. So the Claude versus Codex case does not prove that one system is better. It proves something more useful. The model can run out of capacity. The vendor can change. The price can move. The next release can reverse today's ranking. But a documented workflow, inspectable state, and hard acceptance criteria can survive all of that. The smartest agent in the room is temporary. The operating system you build around it is the durable asset. Follow me, and I will see you in the next one.